In this video, we're going to go over factoring trinomials that have a coefficient that is greater than 1. Here are the rules for factoring trinomials with a coefficient greater than 1. Always check the greatest common factor. Regardless of what you're factoring, always check the greatest common factor first. Sometimes it has a greatest common factor and sometimes it doesn't. Next, you're going to make two sets of parentheses. Here's what you put in those two sets of parentheses. Put the first number in each set of parentheses and then split the variable. Next, you're going to find two numbers that add up to be the middle number and multiply together to get you the product of the first and last number. And then we're going to go through this process of reducing. So here's an example of me following these rules right here to factor this trinomial. The very first thing I'm going to look for is the greatest common factor. Is there a number that will go into each one of these? No. Next, I want to make two sets of parentheses. Once I make two sets of parentheses, I'm going to take this first number and I'm going to put it here in the front, and I'm going to split this variable up. Meaning this, it's an x squared. That means I'm going to put an x in this one and an x in this one. If it was x to the fourth power, I'd put x squared in this one and x squared in this one. If it was x to the sixth power, I would put x to the third in this one, x to the third in this one. That's a clue as to which one of these can probably be factored. You need to have an even exponent right here. So since this is a 3, I'm going to put 3x in this parentheses and 3x in the other parentheses. Next, I need to find two numbers that go right here. These two numbers have to add up to be this middle number and be the product of these two numbers multiplied together. So these two numbers multiplied together, 3 and negative 8, is negative 24. So I'm looking for numbers that multiply together to give me 24. And I'm going to make a t-chart over here to give me a list of those numbers. 1 and 24. Any way I can add or subtract these numbers and get 2? No. 2 and 12 also multiply together to give me 24. Any way I can add or subtract these to get me 2? No. 3 and 8. Any way I can add or subtract these and get 2? If I add them together, I get 11. If I subtract them, I get 5. Those aren't the two numbers I'm looking for. 4 and 6. 4 times 6 will give me 24. Any way I can subtract these and get 2? Yes. What kind of 2 do I need? I need a negative 2. So one of these needs to be a positive 4 and a negative 6. Positive 4 and negative 6 added together give me negative 2, and when I multiply them together, it gives me negative 24. It doesn't matter where I put these numbers, whether I put them in the first set of parentheses or the second set of parentheses. My last rule is to reduce. Here's what I mean by reducing. I'm going to reduce each set of parentheses like it would be a fraction. For instance, is there a number that will go into 3 and 4? No. That means that part is reduced. I bring it down. Is there a number that will go into 3 and 6? Yes. I'm going to reduce this set of parentheses then. What number will go into 3 and 6? 3. I'm going to divide both of these numbers by 3. 3 divided by 3 is 1x. And negative 6 divided by 3 is negative 2. I just factored this trinomial. That was our first example. Let's do another example. So again, if the leading coefficient is greater than 1, I have to go through this process to factor it. Always check the greatest common factor. Is there a number that will go into 3, 7, and 6? No. So this one does not have a greatest common factor. I'll go ahead and make two sets of parentheses. What do I put in the front? I take this first number and I split the variable up. This is 3x squared, So I'm going to put a 3x right here and a 3x right here. I'm going to do something in a minute called reducing that's going to get rid of one of these 3's. I need two numbers that go right here. These two numbers have to add up to be this and multiply together to give me negative 18. So let me say that again. These two numbers have to add up to be 7 and multiply together to give me negative 18. So I'm going to make a list of numbers that multiply together to give me 18 and see if I can add or subtract them and get 7. Start with 1 and 18. Anyway, I can add or subtract 1 and 18 to get 7. If I add them, I get 19. If I subtract, I get 17. So those aren't the two numbers I'm looking for. Will 2 go into 18? Yes, 9 times. If I add these together, I get 11. If I subtract them, I get 7. These are the two numbers I'm looking for. I need a positive 7. So the larger one needs to be positive. I want to put a negative 2 right here. Doesn't matter which spot I put the numbers in. And a plus 9 right here. I've got one more step I need to do here. I need to reduce these parentheses. This first one, is there a number that will go into 3 and 2? No. So I keep that one the way it is. The second one, is there a number that will go into 3 and 9? Yes. 3 will go into both of those. That means I divide both the first one and the second one by 3. 3x divided by 3 is x, plus 9 divided by 3 is 3. There's that trinomial factored right there. Next example. The very first thing I need to do is check the greatest common factor regardless of what type of problem I have. Is there a number that will go into 2? There's a 1 sitting in front of there, 1 and 1. There's nothing significant that I could factor out. I could factor 1 out. It's not going to help me. I make 2 sets of parentheses. Since there's a number right here, I'm going to put a 2 right here and a 2 right here and split this x up. X there and an x there. I'm going to reduce here in a minute and it's going to get rid of one of these 2's. I'm looking for 2 numbers to put right here. These 2 numbers have to add up to be the middle number. What is the middle number? Negative 1. There's a 1 sitting in front of that x. And they have to multiply together to give me the product of these 2 numbers. Negative 2. So what are numbers that multiply together that give me 2, 1, and 2? That's it. If I add or subtract these, how can I get a negative 1? I can put positive and negative signs with these 2 numbers and get a negative 1. To get a negative 1, I better have a negative 2 and a positive 1. I need to reduce. Is there a number that will go into both of these? Yes, 2 will go into both of these. 2x divided by 2 is x. Negative 2 divided by 2 is negative 1. Is there a number that will go into both of these? No, so that one stays the same. There's how you factor something. Here's how you factor a trinomial with a leading coefficient greater than 1. Next example. Always check the greatest common factor first. Is there a number that will go into 2, 13, and 24? No. So I'll go to my next step. My next step is to go ahead and make 2 sets of parentheses. I take this first number right here, put it in the front, and split this x up. Put an x here and an x here. In a minute, I'm going to reduce this, and it's going to get rid of one of these 2's. I need 2 numbers that go right here. These 2 numbers have to add up to be 13. They have to multiply together to give me what? 48. Where did I get the 48 from? 2 times 24 is 48. In fact, it needs to be a negative 48. So I need to list numbers that multiply together to give me 48 until I find 2 that also add up to be 13. 1 and 48. If I add these, I get 49. If I subtract, I get 47. Not the 2 numbers I'm looking for. 2 and 24. If I add these two numbers together, I'll get 26. If I subtract, I get 22. Still not the two numbers I'm looking for. 3 and 16. If I add these two numbers together, I get 19. If I subtract them, I get 13. I need to get a positive 13 out of these two numbers. So a positive 16 and a negative 3 will give me a positive 13. And if I multiply these two numbers together, I get negative 48. And that's what I'm looking for. Two numbers that add up to be 13 and multiply together to give me negative 48. I have one more thing I need to do, is reduce this. Is there a number that will go into 2 and 16? Yes, both of these can be divided by 2. 2x divided by 2 is x, plus 16 divided by 2 is 8. Is there a number that will go into these two? No, so it stays the same. Here is the answer for me factoring this trinomial. Next example. Here's an example of something that does have a greatest common factor, because right now multiplying these two together is going to give me a really big number. But if I go ahead and factor out the greatest common factor, it's going to make this problem easier. Is there a number that will go into 6, 27, and 21? 3. Divide each one of these by 3. 6x squared divided by 3, 2x squared. Plus 27x divided by 3, 9x. Plus 21 divided by 3 is 7. I need to keep this 3 on the outside and continue on with the rest of what I need to do here. I still need to make 2 sets of parentheses. So keep that 3 on the outside. Make 2 sets of parentheses because I'm splitting this part up now. I look here in the front. It's going to tell me what to put in the front of each one of these. 2x. I am now looking for two numbers. These two numbers have to add up to be what? 9. But when I multiply them together, they should be what? 14. So I'm going to look for numbers that multiply together to give me 14. 1 and 14. Any way I can add or subtract these and get 9? No. Add them together, I get 15. Subtract, I get 13. 2 will go into 14. 7 times. Any way I can add or subtract these and get 9? Yes. If I add 2 and 7, I get 9. So those are the two numbers I'm looking for. These two numbers multiply together to give me 14 and add together to give me 9. Got to remember to keep this 3 out here. I am now reducing these, the ones that need to be reduced. Is there a number that will go into 2x and 2? Yes, 2. 2x divided by 2 is x, plus 2 divided by 2 is 1. Close that parentheses. Can this one be reduced? No, so I keep it the same. There's how you factor something that has a leading coefficient greater than 1.